Welcome to this video lesson over limiting reactant, which is basically the same thing that we've been doing for stoichiometry problems, except that we're going to have to work the problem twice. So far the problems that we've been given just had one reactant, but in real life you obviously are mixing two reactants together, and so we have to figure out which one will run out first. And so these types of problems are called limiting reactant or limiting reagent. Both words can be used, so you can just kind of write that in those blanks, because they go right here. Okay? The way that you'll the way that you'll recognize that it's a limiting reactant problem is you're going to be given information about both reactants. So you'll be given two numbers, whether it's liters or grams or moles. Excuse me. Okay? So whichever, so basically you're just going to work the problem twice. And then whichever reactant produces the smallest amount is called the limiting reactant, because you're going to run out of it first. So the definition of limiting reactant is basically what runs out first. It controls how much product can be made, because once you run out of it, the reaction stops. And the excess reactant is the substance that is not used up completely, and it's left over. So probably you've noticed in a couple of problems we may have said something like excess sulfuric acid reacts with sodium chloride, and what happened, how much product can you make? Well, now it won't say that. It'll give you information about both. So we're going to work two examples. By now you've probably practiced the stoichiometry and hopefully have it down, so now this will just be an extra step. So in this problem we have silicon carbide, which is used to make car brakes and bulletproof vests, and it has this equation which is already balanced. So we always double check to make sure it's balanced, so we say check. Okay, so it's given us 25 grams of carbon and 25 grams of the silicon dioxide. And it wants to know what is the limiting reactant, how many grams of product can we produce theoretically, and then we want to find out how much leftover we have. Okay, so we're going to start with, it doesn't matter which one you start with, I usually just start with what they gave me first. So we're going to have 25 grams, and that's going to need three significant figures when we get to the end. 3. So we got that out of the way. So we have 25 grams of carbon. We're going to divide by the molar mass of carbon, because we have to be in moles to do our mole ratio. I go look at my ratio, and I have 3 moles of carbon for every 1 mole of silicon carbide that we can produce. Cancel, 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 cancel. And then the molar mass of silicon carbide is 40.10. And I do my calculations on my calculator. So if you want to pause at this time and calculate it to see if you get the right answer, go ahead and do that, and then restart the video. And that would give me 27.8 grams of silicon carbide. Now we do not know if that's our answer yet, because we have to calculate for silicon dioxide. So now we're going to say 25 grams of silicon dioxide. Divide by the molar mass, so 60.09. Now our ratio there is 1 to 1, so we have 1 mole, because right here, of silicon dioxide produces 1 mole of silicon carbide. So cancel, 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 cancel. Well, I canceled too soon, but we know we're going to do molar mass on the end, so let's go ahead and do that. Okay, so go ahead and pause the calculator again, and pause the calculator, can't really do that. Pause the video and calculate that, sorry about that. And when I do my math correctly, I get 16.7 grams of silicon carbide, which is my answer because it's the smallest amount. So I could make, theoretically, 16.7 grams of silicon carbide, and SiO2 is limiting reactant, because I will run out of that first. And so that will make carbon the excess reactant. Okay, so the last part of that question ask how many grams of excess reactant is left over. Okay, so we're going to need to do yet another stoichiometry problem. So hopefully you have all this written down. I'm going to erase it and do the excess reactant. So for excess, we're going to do this. We determined that silicon dioxide is our limiting, so we're going to start with that again. And so remember when we first started doing stoichiometry, I told you you can relate anything in a stoichiometry problem to anything else. So it doesn't have to be reactant to product. It can be reactant to another reactant. And so that's what we're going to do. We're going to calculate how much carbon is needed to completely react with the 25 grams of silicon dioxide. So we've got silicon dioxide. We're going to divide by its molar mass. Then we're going to go straight into our mole ratio. So for every 1 mole of silicon dioxide, 3 moles of carbon are required. And then we multiply by the molar mass of carbon. So cancel, 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 cancel. Everything is canceling. And pause your calculator and do that math to make sure you're doing it correctly. And we find out that it would take 15 grams of carbon used in the reaction. Okay? But that's how much we use. That's not how much is left over. So in order to get the leftover, we're simply going to do a subtraction problem. So we're going to start with the original amount, 25 grams. We're going to subtract the 15 grams that we used up, and that would leave us 10 grams of excess carbon. So we would have 10 grams left over. And so that would be that answer. Okay? So if you will turn to the example on the next page of your notes, I'm going to do the first example, and so we'll do that real quick together. Okay, so read in your notes where it says, what is the maximum mass of copper 1 sulfide that can be formed when 80 grams of copper react with 20 grams of sulfur? And then it wants to know what is the limiting reactant. And we're going to add in there also how much excess is left over so that we can practice that. So first things we need to do is they give us the equation of copper plus sulfur making copper 1, so we've got to balance that. And so it's very easy. We're just going to put a 2 right there, and we're done. So they gave us the 80 grams of copper first. Again, it does not matter which one you start with. So we have 80 grams of copper, and I forgot the decimal, but we're going to need 3 sig figs when we get to this. Okay, divide by the molar mass of copper, 63.55. And then mole ratio, 2 moles of copper for 1 mole of copper 2 sulfide. And then the molar mass of copper 2 sulfide, so 1 mole. And that works out to be 159.17 grams. All right, we're going to calculate that, and we get in 3 significant figures from the problems. Let's put the decimal, grams. All right, so now let's do the 25 grams of sulfur. Let's remember the decimal this time. Now, a lot of you may look at that and go, oh, 25 grams, it's got to be the limiting reactant because it's a lot less. You cannot do that because of the stoichiometry of the problem. You can't just look at the 2 masses and go, oh, smallest mass is going to be limiting, because it's not always the case. Sometimes it is, but it's not always the case. So we got molar mass of sulfur. Our mole ratio here is 1 to 1. 1 mole of Cu, oops, sorry, I'm getting ahead of myself. 1 mole of sulfur gives 1 mole of copper 1 sulfide. And then, of course, the molar mass. So when we do those calculations, I get 124 grams. So the answer, always the smallest, is going to be 100 grams. So 100 grams could be theoretically produced, and copper is limiting reactant. So we always want to just kind of, or circle and just say limiting, however you want to do it to signify that. Okay? So the second part of that I added in was let's calculate the excess. So we're going to make 100 grams, copper is limiting, and now let's go see how much leftover sulfur we would have. Okay, so let's put that equation back up here. 2 copper plus sulfur is going to yield Cu2S. All right, so we're going to start with our 80 grams of copper, and we're going to calculate it in terms of sulfur. So molar mass of copper mole ratio, 2 moles of copper, 1 mole of sulfur, and then the molar mass of sulfur at the end. And when we calculate that, we get 20.2 grams of sulfur used. Okay, so now we need to see how much would be left over. So we're going to take the original amount, 25.0, minus 20.2. And this time, since it's a subtraction problem, we're looking at decimal places, not total sig figs. So we have 1 decimal place, so our answer should be 4.8 grams of sulfur left over, or excess, however you want to put that is fine. And so that's how you do limiting reactant problems. All right?